Please welcome StreamNative's Principal Sales Engineer, David Kjerrumgaard, and he will be joined by Adam Richardson, Mingmin Chen, Balu Kunju, Matteo Merli, and Alexander Gallego.
Hi, David. Nice meeting you.
Thank you. Mic working? Testing 1, 2. Testing 1, 2. Can everybody hear me? Great. Yeah. Thank you all for joining. We're really honored to have you all here. Some of the leading developers of the streaming platforms or biggest users of the streaming platforms. We're going to have an interesting conversation today around a few different points, but I want to first give everybody a chance for you to introduce yourselves, talk about where you're from, a little bit about your background as well before we get started. So let's go ahead and start with you.
Sure.
Balu.
Thanks, David. Hello, everyone. My name is Balu. I've been with PayPal for the last 12 years, working on different platform projects. And the last 3 years, I've been in the messaging and streaming world. Glad to be here. Next.
Cool. All right. So first, thanks for having me here. My name is Mingmin, and I have been with Uber for 10 years. Cannot beat Balu in this case. So I joined Uber as a software engineer in the Kafka team. Right now, I'm leading all the online data systems. That includes data streaming technologies, Kafka Flink, Pinot, and also search technologies and all the databases, OLAP, KB store, caching. Great to be here.
All right. Thank you so much for being here.
Hi, everyone. My name is Alex. I am the founder and creator of Redpanda. I've been doing streaming for a really long time. I think basically just right along how much time you've been streaming, like 15 years or so. Excited to be here.
Thank you.
Matteo Merli, I'm CTO of StreamNative, co-creator of Apache Pulsar, and PMC chair of Pulsar.
Hi there, my name is Adam Richardson. I'm the tech lead of the real-time infrastructure team at OpenAI. Been at OpenAI for about 2 years now. Previous to that, I was the tech lead of the data movement team at Stripe.
All right, thank you all for being here. We appreciate your expertise in this. So we'll go ahead and get started. We got a few minutes left, and we're up against drinks, so we always got to worry about that. So we'll talk first about, I have a couple open questions I'll share to the panel, and I'll maybe pose it to one of you, and then if anybody wants to respond, please do. But the first topic is around low latency versus cost optimization. There's always a trade-off, right? Some of these architectural trade-offs. So tell me about a time when you discovered an operational tweak that dramatically improved your tail latency. What was the aha moment, and how did you stumble across this?
Should I start?
Yeah, go ahead, please.
Go ahead.
Yeah, so it's not necessarily related to data streaming system, but at Uber, we run our logging data stack on top of Pinot. Right, and then at some point we noticed the tail. We are running some very simple queries, and most of the server respond within tens of milliseconds, right? But we noticed like P95, it really jumped up to like hundreds of milliseconds, and it's a very simple query. We cannot figure it out why. But after digging more into what happened, we noticed it's due to the GC process, right? And we at the end we do Java upgrades. We upgrade from Java 17 to 21, and then we change our GC from GNGC to generational GGC, and it turns out it helps a lot, right? It really reduces our P95 latency, right? It's really the aha moment for me, right? And later I noticed many other companies are already making Java 21 and generational GCC as the default. So I would recommend everyone trying out. It's definitely helping.
Yeah, that's great. Definitely upgrade your Java because the garbage collection gets better over time, incrementally better for sure. Other platforms don't use at all, but you defer the costs like C++ and Malloc, and then you have other issues for sure. So thank you for sharing that with everyone on that. Anybody here, please tell us about one of the most expensive reliability investments you had to make. What was the one additional 9 of uptime that cost you a fortune, and when do you question if it was really worth it, right? Because you have to be available 24/7, and what sort of change did you make that really, to stretch your uptime availability, that was really maybe not worth it in retrospect?
I can take that up.
Yeah, please.
So for us, moving into Pulsar itself is a big investment, correct? For example, in PayPal, that we have an in-house product for the messaging platform. And that has been running for more than 15 plus years. And then it has the data store, a database-based data store. And for us, the operational cost was around 10 to 12 million. And then just moving to Pulsar itself, it's a real investment, the reliability investment, correct? And which itself, it's an aha moment for us. In terms of moving from the latency from seconds to sub-seconds, itself, it's a big investment for us. And thanks for StreamNative team to help us setting it up in our live environment. And yeah, that would be my take for that.
No, yeah, we definitely appreciate the good press. We're glad we're helping to do that for sure. So yeah, thank you for that. Can we go on to the next topic? Where's running the slides?
Oh.
I don't have the slide clicker. So there we go.
Yeah.
Thank you. So a little bit maybe for the developers over there, like Matteo and Alex, for sure. So if you're, paint a picture of the streaming architecture you think we'll be building 10 years from now, 2035. Are we heading towards a world where object storage becomes a source of truth? And what does that mean now, and how we think about data ownership? Like, what do you think we're building? What are you guys building for the next 10 years for us to work on? Alex, please.
Let's see, what are we building towards? Architectural shift. I think today you cannot build a cost-effective solution if it's not on tiered storage. Actually, all databases do, right? But the way that I would encourage people to think about it is similar through the memory hierarchy, where you have like L1, L2, L3, L4. Talking about latency, like the closer it is to memory, the kind of the more expensive this is. But the general takeaway and where there's really two design dimensions, at least for Redpanda. One is reducing the metadata overhead. So if you actually trace what has yielded economies of a scale, is around reducing the cost of metadata. And when it comes to like the topic partition lookup for the Kafka, in the Kafka parlance, that really is it. Or like the metadata around replicating offsets across a raft group or whatever is your consensus protocol. Like if you can reduce metadata, I was talking to Ram, who's a researcher and a professor here. If you can reduce the metadata overhead, then I think you can give rise to a new order of magnitude systems that are larger than we're seeing today. The issue with that is that these protocols are co-designed with the client. And so it's not enough for the broker side, so let's say like Redpanda or whatever, it has to be co-designed with the client application because the client will just end up bottlenecking. By way of a story, we have one of the largest gaming companies in the world, and they were at something like 60,000 unreplicated partitions, and then with replication, it was large, and it was like 5.4 gigabytes per second metadata sustained writes. And they're like, hey, we're not getting any data. I was like, actually, we're saturating your wires because it's like 5.4 gigabytes per second sustained metadata writes. And so I think that's an important design dimension that we're working towards. Like, what is the next evolution of Redpanda? It's all about reducing the metadata overhead. And then the second one is it is untrue that you need to design between local first systems like a DuckDB versus the Snowflake distributed query engines. In a streaming, it's really all about concurrency and parallelism are two separate design dimensions, right? Concurrency is about software structure, and parallelism is about the simultaneity of execution. And you can design an actor-style framework that can scale from a single P thread to a petabyte scale. So those are the two dimensions where we're taking Redpanda.
Okay, yeah, great. Thank you for that. Matteo, what are we building here at StreamNative?
What are we building? I think that what we're building depends. I mean, what everyone is building depends also on the environment, right? 20 years ago, you were primarily on-prem. You were designing for the environment you had available. You were optimizing both the design and implementation for those. Then system evolves, and environments evolve, and the system sometimes lag behind. So you have to sometimes take a step back and say, yeah, we cannot just evolve these things, and to make it work perfectly in the new world, we have to get rid of something and restart fresh, at least not everything, but at least critical components, and rethink them, challenging the initial assumption that they're not true anymore. So, but these pushes are coming from outside forces like cloud vendors. The economics of these are influencing the trends, and that's something that's outside the control of most of us. So we have to kind of deal with it. And if you get pushed in one direction, you have to kind of embrace it in a way, and make the best of it. There are a lot of good things in the new environment, like object storage and training toward lower latencies. But there are more constraints, so you have to kind of get along with those constraints and take the best out of it. I know it's a bit generic question, not getting into any specifics right here, but.
No, that's fine. Yeah, thank you for that. So I'll flip. So that's we've heard from the builders, now the consumers. Are they building you what you need in the future, right? So I was at the OpenAI talk this morning, and they said, yeah, Kafka's great as long as you get rid of the partitions and you get rid of ordering, then it works great for us, right? So they didn't really build you the right system. Based on what you've heard, are they building what you need, or what do you want us to build you would be for a consumer? Yeah, go ahead.
Yeah, I think there's always an element of path dependence here where, if we were to relitigate every design choice that OpenAI has ever made historically, maybe we'd take a different system off the shelf today. But really, moving forward from our historical choices, building around Kafka and extending Kafka has been a pretty pragmatic choice. And I do actually think that something that I think we benefited from quite a bit is like this proliferation of more and more Kafka-compatible engines, even if they make potentially very different implementation and design choices internally, but that are nonetheless externally compatible. We found that having this sort of pluggable ecosystem where we can introduce different engines depending on the specific use case has been very high leverage for us. Tiered storage is one example of that dynamic, but also even like entirely different implementations. And so from that perspective, I'm sensitive to the idea that maybe we do need new clients in some cases, but working within the Kafka protocol has been pretty high leverage for us so far.
Yeah, great. That's really insight. So share your take on when traditional architectures remain unbeatable, right, versus when you'd be willing to take on a diskless or leaderless architecture, right, since you have this proliferation of different quality of service products that are Kafka compatible. Any thoughts from the panel, from the consumers on what would drive you in one camp versus the other, if you want to?
Yeah, I can. I would say that overall, we're very excited about diskless architecture, and I'm personally very excited. I think it's an extremely cool new technological evolution. I would say that there's always this, the appetite to adopt something extremely powerful versus the risk of adopting something not so proven in production. And not to criticize any implementation specifically, but I think there's always like the impulse to wait a little bit and see how the space evolves and see how these systems actually work in prod at scale from other peer companies. And so, we've very recently adopted tiered storage at scale for basically all of our Kafka topics. I expect that diskless will come. It may be another few months, another couple of quarters, but I do expect that we'll evolve in that direction as well.
Okay, great. Anyone else, Uber, or want to?
I mean, Uber is running real-time business, right? Our ride-sharing business, our Eats delivery business, all relies on data streaming technologies. And we have been running on top of Kafka for, 10 plus years already, right? And those our business is really critical, and we are open-minded to try out like this leaderless architecture. But in the meantime, we do need to make sure like quality and reliability is our top priority, right? Sure. We don't want to saturate like our reliability because of trying our newer alternative as such, right? Because a small mistake could wipe out the efficiency gains that we get from multiple years of effort. Yeah. But that being said, there are certain workloads that are more volatile, and that could be a good fit, like for diskless and leaderless architecture. And of course, we are trying out different kind of options in the community, open source ones, right? We will see how it goes, and we are willing to take other options in our tech stack.
All right. Sounds great.
Yeah, so in PayPal, coming from a fintech background, correct? We would definitely wanted to explore those opportunities as well, the leaderless and then the diskless. But our primary criteria would be each and every transaction is basically a payment for us, correct? So we would stress on the fact that how would I secure the transaction as soon as we receive it, correct? And also in future moving forward, we will probably have an explore the opportunity of having a multi-tier storage, for example, a hot tier, and then the warm tier, and then the cold tier, depending upon the events that we receive. For example, the event that is most needed at the different set of microservices, we try to serve it out of the hot memory, right? And then the past events, probably we will store it in object storage where we can keep it for some time. And later for the auditing and for the compliance report, probably we will store it. So we will definitely explore moving forward in those architectures as well.
Okay, great. Yeah, thank you everyone for that. So the big one, AI agents and new requirements, right? So talking about AI agents, everything's in AI right now. So walk us through the infrastructure evolution you're seeing within agentic AI. What capabilities these systems demand that your current stack wasn't anticipating?
Yeah, I can go first.
Sure.
So yeah, this is definitely an interesting field that we are exploring, correct? Example, implementing in our different stack. One of the points that we are wanted to be very careful when we explore this, how do we handle this certain unpredictability factor that we have in the AI world, right? For example, when you ask about show me the payment that I made in the last 10, 15 days or even months, it's going to spawn a lot of micro jobs or tasks. And how do I accommodate that in terms of infrastructure? So to me, this is going to explore the gray areas of the infrastructure layer, correct? So we wanted to basically find out how much we can adopt those unpredictability that AI is going to bring in terms of infra layer. So it's still in the more of a POC phase, but we will try to get more on this.
Yeah, oh yeah, for sure. Any other comments? Anybody else want to jump in? Matteo? Or?
I think I can maybe add around what the conversations I'm having. And so,
Sure.
You know, by way of introduction, Redpanda, I guess take it with a grain of salt, because I only tend to speak with Global Fortune 2000. There just tend to be the people that I have a chat. And so I'd say I have a couple hundred chats a year on this, right? I think as it relates to streaming, there's like two big categories. One is authorization and authentication of agents. So you have this digital workforce. And where the world is today is not as advanced as they seem to be. They're still on like OBO permissions on behalf of Alex. Like I'm an agent, I'm going to act on behalf of Alex, and I'm going to go and achieve a task. Okay, that's great. And so that's still that authorization and authentication mechanisms where most backend systems are API token-based, which is basically root or nothing. That's a real problem that people are seeing today. The second problem is this idea of model replay. And you know, we don't power OpenAI, but we power other model companies, foundation model companies. And what we're seeing is like, okay, you have this fleet of agents. If something goes wrong for something real, like a credit card application, how do you go back and debug not just the model decisions, like, okay, maybe the temperature was like 0.7, and then it says like, my wife doesn't get the credit application, right? Because whatever, it chose left instead of right. And so reconstructing not just the model decisions, but the entire transitive dependencies of the tools, like what credit bureaus you took, what databases, what user agents. And so from a distributed log perspective, being able to go back and time travel debug and reconstruct the session, it's something that people are using, you know, a distributed log for today. And there's like obviously many implementations. Redpanda, there's Kafka, there's Pulsar, but the core concept remains of how people are building these agents in the enterprise.
Yeah, I mean, similarly, I don't think there is anything fundamentally different in the requirements for like agents, AI, or like even model building is kind of like as an infrastructure builder, right? You see that more like at the lower level, you see kind of the same pattern, the same needs. I would say there is an explosion in data needs in a way. Like the more people will actually need more data and want to have more control. And also, like there's a variety of use cases where you either sometimes there's like data feedback loops, building those kind of feedback loops to get data to feed into models, or where you have more like worker queues in kind of like how this agent collaborates and communicates between each other. So it's kind of like a bit varied, but it's like nothing extraordinarily different from the traditional messaging and streaming space. Just more and more data, more and more sources, more and more places where people want to push data and read data from.
All right, great. Yeah, thank you everyone for that. Any other, we'll talk about AI and OpenAI, you got something to say about it?
I think it's pretty early days, I would say, for integrations between the streaming platform and our agentic workloads at OpenAI. I don't want to speak out of turn here. I think that as the space evolves, I think that as models get more sophisticated and get better at driving long-running tasks, I think there'll be sort of a stronger case for integration with the existing highly durable, highly available streaming primitives that we have in-house. I think we're not quite there yet, and we're sort of watching the space closely and seeing how it evolves.
Okay, yeah, great. Thank you for that. So second to last topic, convergence versus specialization. So just like a greenfield thought experiment. Tell us about a streaming platform you'd build if you could start from scratch tomorrow. What single design priority would drive every other decision, right? You're going to build a new streaming system. What would be your North Star? What would you rebuild it, architect it around? Either as a consumer or as a developer. Or is that too hard a question? Design me a new streaming system right now.
I think that one priority that we've really elevated at OpenAI for our internal use cases is infrastructure flexibility, even occasionally at the cost, to my coworker Arvin's talk earlier, even potentially at the cost of some of the lower level capabilities of systems like Kafka, like ordering and partitioning. And I certainly wouldn't suggest that's a one-size-fits-all solution. I think it's very dependent on the specific environment, the specific company, and the use cases in any given environment. But I do feel that that specific choice has been extremely high leverage in terms of our ability to scale. And I think that in some ways you've had to retrofit those capabilities onto the existing Kafka platform by building systems around it. From that perspective, it might even be nicer if we had a system that didn't have those capabilities intrinsically and that was more scalable as a result.
Okay.
I guess I'll make a comment as a builder for infrastructure. I guess most people here would probably be people consuming the stuff that we tend to build. There's I think two major convergence that I see. There's basically on the analytics space, it's like how does this thing integrate with Iceberg? Iceberg being an open format. I think Delta may be even a little bit better, but like the world converged on Iceberg, and so therefore like that Iceberg is a real thing. Two, there's this like idea that I think that the DuckDB folks did a really great job, which is like actually most data is not big data by count, actually not by size, by definition. And so there's, in my opinion, there's like this new way of systems design here where like there is no technical reason why you wouldn't be able to scale from a single thread to like a cluster. Mm-hmm. I think by separating that design space of concurrency and parallelism, like the simultaneity of execution being a runtime variable, so you can deploy the same code on a 96-core VM in Amazon, or like be embedded in submarines for, by way of example. And so I think those are important design decisions. If I were a system builder today, it's like I don't understand why you couldn't get both. Right. Why can't you win at both ends? And so anyways, I'll kind of stop there on the design decisions I'm seeing.
If I were to design like a streaming system, from scratch today, of course, I would start from like a cloud native and think about, because I guess most of the companies are mostly just running on cloud, right? And as part of like Uber's journey migrating to cloud, we are running into various issues, with the cloud vendors, right? Of course, if I want to design the system from scratch today, I will start from like object store first, right? Because that's more cloud native, right? And it helps resolving some of the challenges with the existing systems like Kafka, right? There are really expensive data copying replication, right? Because of due to the nature that it heavily relies on the local disk. And the new system, of course, cloud native, would put like object store first.
Yeah, but to challenge that, though, like I think Matteo's point was actually like relevant. Like it's the co-design that these clouds enforce on the developer actually building the system. So Azure removed the cross-AZ network transfer, right?
Yeah.
And so that's only true because like Amazon doesn't charge themselves for their internal services. They'll charge us all, but they don't charge themselves for their internal cross-AZ replication. But so if you remove that, then I think the design is space different. And so I would agree that like I think today it makes sense for some clouds, but I would argue that I think Matteo's right is on the like the intuition is that you kind of have to co-design around like, okay, what's available today? And so maybe for some clouds it is cross-AZ, but not for all.
Not for all, yeah, definitely.
I would add one thing, if I could redesign. I agree on the cloud side and like design for that. Not that we make any mistakes in Pulsar, but something might be different today. But one thing that I believe that the whole streaming world could improve a lot would be on the client semantics, client APIs, the way you put these APIs in front of developers. I think today, all the systems are way too complex, and it's sometimes can be very difficult for application developers to understand all the subtleties of these semantics, how they can use it, how they can use it in the right way, and the API is like huge. There are many different concepts that are clashing between each other, like from partitions to ordering to like things that have nothing to do with how developers think their applications. So I would like to go with a different set of APIs for different kind of use cases. Like you have only a very constrained API that you can use for this is the SDK if you want to do this kind of application. This is a different set of APIs if you want to do something else that is just like reducing that API surface that a developer has to understand and to be like very proficient in building like a reliable application. So that's where I will look at it.
So I'll do it and pitch a little idea that a friend of mine were talking about a little bit. We proposed something for the community around a quality of service metric. So invert sort of the process. And today you either get a system that's object storage and you trade off latency, or you go with local disk and it's very low latency, where the client can say, I want this amount of data, I'm willing to tolerate this allowance of performance, and you can negotiate that on the front end as a client perspective. Thoughts on that idea? Like we kind of kicked around, I thought was pretty cool. Would that just be too hard to build something like that, or are we just thinking science fiction? Thoughts on something like that sort of approach? Because it's not a one size fits all, right? And so you want to have multiple clusters to fit different use cases. Thoughts on something like that, design-wise? Any?
Yeah, so we do have some kind of discussions happening around let's say, having a use case footprint or a versioning footprint of any incoming message, correct? If I have the ability to conclude or derive what is the storage that I should use, for example, correct? If that is not a very high, for example, if I have to quote a specific use case, when I make a payment and I should make a decision on a split second whether it is a legitimate payment, is it a risk involved in it, correct? So that has to be served on a very immediate low latency to all the other microservices. Against, let's say, an event that I need to store, which might be needed on a later point of time, correct? Then I can, if I derive this kind of conclusion, then I can associate what kind of storage that I can allocate to that, correct? So that level of experiment also that we are thinking about moving forward in the streaming world, David.
Yeah, you definitely have the low latency. Is this
Yeah.
fraud detection or not? But I also have to store it for 3 years for auditing
Yes.
in the future if somebody wants their money back.
Yes.
Yes, absolutely understand
Correct.
that for sure. So, do you have a comment or anybody else? That's all right. Okay, making sure. Lightning round. We're almost done. We got 5 minutes left here before we go get some drinks. So the one metric, share the metric with P95, P99, recovery RTO that kept you up at night until you absolutely fixed it. What was the exact figure that forced your hand to finally make a system change? You were chugging along. Finally, this metric was just too high, and you had to change it. Anybody take first stabs at that? Yeah.
Yeah. So if I would pick one metric, I would say recovery RTO.
Okay.
The reason being, everyone can make mistakes. Right? We push code every day. We could introduce a bug, and it's okay. It's okay to have some issue. Mm-hmm. But we need to have a mechanism to recover our system in a fast fashion, right? And then if we have the automatic system to detect the issue, to mitigate the issue, to recover the issue in a fast fashion, then I will go to sleep very without any worrying about our system, right? But if we don't have that, then it will keep me up at night.
Oh, yeah, that's a great point. So was there a specific number you were targeting at Uber for RTO and that you were above and then you figured out a way to get below that? Or?
It all depends on the system we are talking about, right? If it's part of our critical chip serving stack, of course, we are targeting in terms of 5-10 minutes, right? Of course, it depends on the issues that we run into, and sometimes we cannot necessarily always meet this RTO, right? But that's a goal, that's a target we want to hit.
Yeah, that's an often overlooked metric. Everybody's talking about latency and throughput and these sorts of things, but yeah, keeping a system up lets you sleep at night for sure. So, yeah.
I'll share one really, really hard to debug metric that we fixed for Google Cloud. I won't tell you the feature, but it was a kernel bug that we found. So we use kernel bypass, and typically a page write it's a few microseconds, right? So think 8 to 26 microseconds to write a memory aligned page to the underlying device. And on GCP, it was multiple seconds. I was I don't know what the hell this thing is doing. Multiple seconds for a system. It's did the thing go off for smoke? What is it doing? And then we replayed that, and it wouldn't happen in Amazon, and it wouldn't happen on Azure, and it would just happen on GCP. Anyways, it turns out there was a kernel bug that we fixed it for all of you. You're welcome. But it was a firmware bug in the kernel that we found. And I was how is it possible that we were the ones that found this bug? There's all these large companies running on it on this local storage device. But it took months, and it was this escalation. So we run a large payment system, and they were just hey, every now and then your system stalls. And I was that doesn't make any sense. I wrote the code, right? And it turned out to be true, but it was a kernel bug, and that was really hard too. Probably one of the hardest bugs that we've chased.
So it manifested itself as a P99. Everyone thought this would be a huge spike.
Yeah, basically the payment didn't go through, and you're just okay, I don't know
wow.
what, because it's multiple seconds, and the kernel was just locked.
Wow.
And we were doing everything, and so anyways, eventually they patched the kernel, and it's all great. And so
that's a great story. I'm sure Google didn't give you any credit for that. I'm sure.
They should share revenue with us, though.
Okay, great. One practice, so share the one change you made to make the team visibility better. What habit, process, or configuration became the thing that you'd implement first in a new company, right? What was a process thing, something you guys managing these large systems, decided this is what makes everybody see things the same way, we're aligned on what we're trying to achieve as far as our North Star, and this is I'm taking this with me to my next company no matter where I go. Any,
I can answer that.
Sure.
So one thing that I would definitely do is for example, we can build the solution, correct? But I would definitely stress on the point, the product lifecycle, the chaos engineering around it, correct? Because most of the time when we see issues is around the corner cases when we rolled it out into the live environment. how do I catch that in the QA environment itself, right? So there should be a lot of time that we should spend. I know we have some kind of chaos engineering, but we should still find out how I can have these methods or practice within the team to think through all these corner cases and then catch them in a very early stage, correct? Because that will help a lot of time once it is probably find that in the production environment, it will have a lot of impact in the revenue and all those things. So that our habit or the process change I would definitely do in the new company or something.
So going forward, you start that on day one. You would start torpedoing your system as soon as you implement it.
Yes.
See how things happen. Yeah, for sure. A lot of people are too busy getting up and running, and then they
Correct.
don't touch it.
Correct.
Just keep it running. So for sure. I know we've gone a little bit over. Any other comments on that?
Yeah, one practice that I think we've adopted at OpenAI, mostly based on experience from previous gigs on the team, just a general norm of aiming for transparent migrations anytime you need to make a large-scale change affecting either external or external users. What I've seen historically is that any change that requires the collaboration and cooperation of all of your user teams, maybe hundreds of user teams, it's likely to fail, or at least take much longer and be much more costly than you would ever have hoped. And so I think that both aiming always towards transparent migration, centralized on a platform team that can build tools and processes around that change, and also introducing appropriate abstractions to facilitate that kind of change, stuff like proxy layers or libraries, that's been a pattern that we've run that playbook repeatedly at OpenAI. And I think every time we do it, we have a little bit more confidence that really this is the right way of doing large-scale changes in our software.
Yeah. For sure. All right, well, thank you. So we won't torture anymore. Thank you so much, gentlemen, for sharing your knowledge with us and coming on the stage. We appreciate you. Thank you so much for coming. And let's go have a happy hour. Thank you so much.